All right, everybody. So we're in section 5.2 again. This time we're factoring difference of squares and perfect square trinomials. So these are special products. And we've dealt with these before, right? Difference of two squares is a situation where you're multiplying two binomials together which have the same two terms, right? But they have a different sign. And usually the middle sign is the sign that's different, okay? And remember that what happens when we FOIL this is we get a times a, which is a squared, a times negative b, which is negative ab, b times a, which is positive ab, and b times negative b, which is negative b squared. And so what happens is we have these two like terms in the middle, negative ab and ab, and they cancel each other out, right? And so what we're left with is a squared minus b squared. Okay? All right, so that's the first type of factoring we'll work with, and this one is probably the easiest to identify of the perfect square or the special products, and probably the easiest to work with. Okay, so just to kind of reiterate and just help us understand, just knowing how to multiply these and what happens when you multiply these binomials can help us to understand why the factoring works, right? Because remember, factoring is kind of reversing the multiplication. Okay, so if we look at number one here, if I FOIL this, x times x is x squared, x times negative 5 is negative 5x, 5 times x is positive 5x, and 5 times negative 5 is negative 25. So we can see that what happens is these like terms, negative 5x and 5x, cancel out, and we're left with x squared minus 25, right? Now, the shortcut is instead of, or well, what we're going to do is, I should say, because we did have a shortcut to get from here to here, but now we're going back the other way, right? We want to go from here to here. So what we can do is we can say, okay, well, what is the square root of x squared, right? And that'll give us x, and then we put that here and here. And then what's the square root of 25? Okay, which is 5, and we put that here and here, and then we just put a plus in one and a minus in the other, and we're all set. Okay, just to show you it always works, let's try it with one more. So if I were to FOIL this out, 6y times 6y is 36y squared, 6y times 8 is positive 48y, negative 8 times 6y is negative 48y, and negative 8 times negative 8 is negative 64. Okay, so once again, we have these middle terms that are like terms and they're opposite, so they cancel out to 0. So they go away, and then we end up with 36y squared minus 64. Okay. All right, so notice how these are perfect squares, right? That's why it's called a difference of two squares, because this sign always comes out negative, because you always have a positive times a negative, or a negative times a positive, right? And so that's why it's called a difference. And there's two, you always end up with a binomial because the middle terms cancel out, right? So it's a difference of 2, and then once again, these are perfect squares, right? And so it's a difference of two squares. All right, remember what we're trying to do is go from here back to here in today's lesson. So we take the square root of 36y squared, and that gives us 6y. So we put that in the first location, or on the left. And then we take the square root of 64, which is 8, and we put that here and here. And then we just put a plus in between one set and then minus in the other. And that's how we factor difference of squares. All right, so let's check out number 3. So this is actually what your assignment's going to look like. And it'll just say factor each polynomial or something like that. So here I see it's a difference. There's 2 because it's a binomial, right? 2 terms. And they're both perfect squares, right? 81 is a perfect square. Y squared is a perfect square. So I can do difference of 2 squares. So I'm going to take the square root of y squared, and that equals y. So I'm going to put y in the first spot, here and here. Okay. Then I'm going to take the square root of 81, and this you can do mentally, right? You don't have to write down on paper these square roots, but the square root of 81 is 9. So I'm going to put 9 here and 9 here. And then I just need a plus and a minus, and that's it. Okay, if you're not sure, you can FOIL this out, and it will come back to equal this. All right, try it out if you don't believe me. One thing is the square, just to make sure everybody's clear, if we square a square root, or if we square root a square, these cancel out, right? Another way to think of it is when you take a square root, you're asking what multiplied by itself equals that number underneath, right? And so y multiplied by y equals y squared, and so that's why y is the square root of y squared. Okay. All right, so let's try number 4. So it's a difference of 2 perfect squares, right? This is a perfect square, this is a perfect square. By the way, with variables, whenever the exponent is even, it's a perfect square. All right, so I'm going to set this up. I'm going to take the square root of 9m squared, which is just 3m, right? Square root of 9 is 3. Square root of m squared is m. So I'm going to put 3m here, 3m here. So now I want to take the square root of 16, which equals 4. So I'm going to put a 4 here, a 4 here. And we just need to put a plus and a minus just to show you it doesn't matter the order. I'll do it that way. And that's it. That's how we factor difference of 2 squares.